3.3 power of a power. All right, today we're going to be talking about multiplying when we have a power. We have x to the fourth power to the second power. So power to a power, we are going to be multiplying to find that. To find a power of a power, you multiply the exponents. Here you have x to the fourth power squared. That written out in expanded form, that means you have two x to the fourth powers. X to the fourth power, x to the fourth power. Multiply them. That equals x to the, when you have this, 4 plus 4 is 8. Or when it's just power to a power, you can just multiply those two. So in an algebraic model, x to the a power times b equals x to the a b power, because that means you're multiplying your exponents. Some examples. When you have, make this a little bigger, x squared to the fourth power. All you need to do, multiply your powers. 2 times 4 is 8, so we have x to the 8th power. Here, our base is 3, so we have 3 to the 2 times 3, 6th power. For letter C, our base is y. We're going to multiply our powers. 7 times 2 is 14. Now over here, we indicate the brackets. We have a -2, and we talked about how important the parentheses are. So we have a -2 as our base, and now we take 3 times 3, and we get 9. It has to have the parentheses because we have 9 -2's. If the parentheses weren't there, that would mean we would have 9 2's and 1 negative. All right, so you have to have the parentheses. That's that grouping. Now here, you cannot combine x plus 5. We cannot add those. They're not like terms. So that grouping is x plus 5. We must have the parentheses because it goes all or none. It's all together. Multiply our powers, 6 times 3. So x to the 5th power, that group to the 18th power. Here we have the group x minus 3. Multiply our powers, 3 times 4, you get 12. Now here it says simplify each expression. Leave answers in exponential form. Leave them in exponential form. Now when we take the first term, we have x cubed times, because that can't be simplified anymore. But now I look at this term. I have a power to a power here. I can simplify that. That becomes x to the 2 times 6 is 12th power equals, now I know those are simplified, so x times x to the 12th. Now we're multiplying. We add our exponents. We get x to the 15th power. Down here, my first term, 3x to the 5th power cannot be simplified anymore. Take that times. I can simplify this one. I can multiply my powers, my 2 powers, exponents right there, and get x to the 4 times 2 is 8th power. Now I can simplify. First of all, 3 times, I multiply my coefficients, 3 and the coefficient to this x is a 1. 3 times 1 is 3. Now multiply x to the 5th times x to the 8th. We add our exponents. I get x to the 13th power. All right, now let's move on. Letter C. Now we get into a problem where we simplify both of them. 4 times 2 is 8, so that becomes x to the 8th power. Times. Simplify this term. X to the 3 times 3 is 9. Add those exponents. we now have x to the 17th power. So all of that problem, that expression turns into simplified to x to the 17th power. Or you could have a 1 there, be the same answer. Right, now we're going to add division into it like we learned yesterday. But before I can do the division where we subtract our exponents, before I can do any of the division, I need to simplify the numerator here. And I can simplify this one. Multiplying my powers, this turns into x to the 6th power. This one times x to the, multiply 2 times 3, the 6th power. Now when I multiply these, I add my exponents, I get x to the 12th power. And underneath, in the denominator, we still have x to the 7th power. Now we're not quite done. We can simplify now by dividing, like we learned yesterday. We have the numerator minus the denominator, 12 minus 7. Those all cancel out, leave me with a 1. 12 minus 7 equals 4, right? No, not 4. What does it equal? It equals 5, right? Common mistakes. Make sure you have all of your little itty-bitty subtraction and addition done correctly. So now we have x to the 5th power left in our numerator. And we have 1 left in our denominator, and that just simply simplifies to x to the 5th power. Now, speaking of a mistake, today on your worksheets, that bottom 11 and 12 go on tomorrow's assignment, so those can be bonuses. And the last one, letter E. Slide that up a little bit. Now, this one. Fun, all right? Gets a little bit more, a few more steps, but still you know all the steps. First thing I need to do is simplify. Can I simplify a negative 40 x to the 5th power? No, because there's no powers to multiply, so that stays the same. Negative 40 x to the 5th power. That can't be simplified anymore. Take that times, however, we can simplify here. 4 times 3 is, that times x to the 12th power, good. Now, negative 40, and remember, what's our coefficient to x? We have that 1. So negative 40 times a positive 1 is still negative 40. How many x's do I have? Well, now we're 5 and a 12. We're going across. We're multiplying. We add these together, and we get 17. Now for the denominator, there's no power to powers here that I need to simplify. But I do need to multiply the two. So 2 times 5 is 10. And then x to the 8th and x to the 3rd, when you add those, when you multiply them, you add the exponents, you get x to the 11th power. Now we're not done. We still need to simplify that a little bit further. We need to divide, and we can simplify the fraction part of it. What goes into both 10 and negative 40 evenly? 10 does, so 10 goes into here once. 10 goes into a negative 40, a negative 4 times. So over here, I've got a negative 4 over 1. That's my number part. Now let's subtract our exponents on our like terms. X to the 17th minus x to the 11th. 17 minus 11 is 6. Those all cancel out. I have 6 left up here. So I have x to the 6th power up on the top. Now this can be simplified because the 1 is in the denominator. It can simply just be written as negative 4 x to the 6th power. All right, and this goes along with your worksheet packets, pages 6 and 7. Pages 6 and 7 in your worksheet packet that you need to do are pages 6 and 7.